Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 27 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 2210. Count hills and valleys in an array. Let's read the problem statement. You are given a zero indexed integer array nums. An index I is part of a hill in nums if the closest non-equal neighbors of I are smaller than the nums of I. Okay. Similarly, an index I is part of a valley in nums if the closest non-equal neighbors of I are larger than the nums of I. Okay. So an index I, okay, let's say this is an index I, okay, is a part of a hill in nums if the closest non-equal neighbors of I are smaller than nums of I. Let's say this is nothing but your I minus 1, okay, closest in the left side, closest in the right side, okay, I plus 1, right? So if this is the case, then this index I is a part of a hill, okay. Same way, an index I is a part of a valley in nums if the closest non-equal neighbors of I, let's say left hand side, here we have I minus 1 index, okay, some value which is greater than this index value, okay, the value at this index, okay. And same way in the right side, let's say I plus 1, okay. So here similarly, an index I is part of a valley in nums if the closest non-equal neighbors of I are larger than nums of I. Okay, so this is part of valley then. Alright, clear? Adjacent indices I and j are part of the same hill or valley if the nums of I value is equal to nums of j. Alright. Note that for an index I to part of a valley or hill, it must have a non-equal neighbor on both the left and right of the index. We have to return the number of hills and valleys in the nums. Okay, very easy problem statement, right? So now see this example number 1. Okay, so here 2 4, okay, so I can say, let's say 2 here, then 4 we have now, so let's say 4 here, okay, 2 here, then 4 here, then after that 1 1, okay. So I can say here we have 1 and then again 1 now. Okay, so let's say again here 1, all right, and then we have 6 and 5, okay. So 6 I can say, let's say 6 like this here, okay, and then we have 5, all right. So here what we need to do, we need to return the number of hills and valleys in nums. Okay, so here if you see this, okay, so here starting from 2 now, okay, we are starting from 2, here 4, okay. So now check for this 4. So for this 4, uh, in the left side the value is smaller than 4 and in the right side also the value is smaller than 4, okay. So that simply means that this is part of a hill, okay, this is hill, right? Now check for this point. For this point here in the left side we have value 4 which is greater than 1, okay, and in the right side this one is equal, right? So ignore this, okay. These are the part of the same value or hill, okay, it is given, right? So after this next point here, if you see we have 6, okay. So for this one, 4 is greater than 1 and 6 is greater than 1. That simply means that this one is part of a valley, okay, and we have to ignore this, okay. So they both are the part of same valley, okay. Now check for this 6. For this 6, in this side we have value smaller than 6 and in the right side also we have value smaller than 6. So this is part of a hill, 2 hill and 1 valley, so in total 3, right? Okay, so here you can see now, read this, okay. So this is your index 0, okay. So at index 0 there is no non-equal neighbor of 2 on the left, okay. In the left side there is nothing, so index 0 is neither a hill nor a valley, okay. So we ignore this. Now at index 1, okay, this index 1, at index 1 the closest non-equal neighbors of 4 are 2 and 1, okay. So this side 2 and this side 1, okay. Since 4 is greater than 2, 4 is greater than 1, index 1 is a hill. Done. Okay. Now add index 2. Okay, so this is your index 2. Okay. At index 2, the closest non-equal neighbors of 1 are 4 and 6. Okay, 1 is smaller than 4 and 1 is smaller than 6. Index 2 is a value. Okay, so 1 is smaller than 4. Okay, this one is smaller than 6. So this one is a part of value. Okay. Now here 0, 1, 2 and this 3 index. Okay, so at index 3, the closest non-equal neighbors of 1 are 4 and 6 only. Since 1 is less than 4 and 1 is less than 6, index 3 is a valley. But note that it is a part of the same valley as index 2. So we have to ignore this, okay? And then after add, if you see this index 4, the closest non-equal neighbors of 6 are 1 and 5, okay? 1 and 5. Alright, 6 is greater than 1, 6 is greater than 5, index 4 is a hill. Done. At index 5, there is no non-equal neighbor of 5 on the right, okay? So in the right side, there is nothing, okay? So index 5 is neither a hill nor a valley. So there are 3 hills and valleys, okay? So we return 3. Okay, 2 heels plus 1 value, so 3, so in total 3. Okay, so that is why we are returning 3. Okay, so this is clear, right? So this is what we need to do. Okay, so from here, for simplicity, I can do one more thing now. Since this is a part of same value, right, 1 1. Okay, so I can ignore this. Okay, these are duplicates, I can ignore this. Okay, so what I'm going to do here, first we have 2. Okay, so here I'm going to write 2, and then after that, we don't have 2 but we have 4. Okay, so I'm going to add that 4. Okay, after 4 we have 1. Okay, so I'm going to add 1. Okay, after 1 we have again 1, so I'm not going to use that one. Okay, but instead of this one, after that we have, I am going to skip this. Okay, since this one and this one both are same, and right, both are adjacent and both are same. Okay, so after 1 I'm simply going to jump to the 6. Okay, so let's say this is 6, I'm going to add here. All right, and then after 6 we have 5. Okay, so I'm going to add 5 here. Done. Okay, so now this is what you need to do. So you can create one array list. Okay, in the list, just check adjacent values. If they are same, just ignore them. Okay, and if they are not same, then just add them. Okay, adjacent values, so just add them, right? So you can use the list. All right. Okay, once this is done, then you have to check this point, you have to check this point, and you have to check this point. There is no need to check these points also. Okay, for this point you have to check both left and right. For this point also you need to check both left and right. For this point also you need to check both left and right. Okay, and just increment the count, right? If it is part of hill or valley, just increment the point. That's it. Okay, very simple. Now let's write the code. Code is not going to be very complex for this, very easy code. Okay, so first create array list integer. Okay, and here you can say unique list is equal to new array list. Okay, this is done, and here you are going to write unique list dot add. Okay, in this just add first, okay, nums of 0. Then start from index I, okay, of 1, right? And here I is less than nums dot length, and here I plus plus, and here just check if your nums of I value, okay, if it is not equal to nums of I minus 1. Okay, if this is the case, right, in that, just do one thing. In that case, okay, if both are not equal, then only add them in the list. Okay, so unique list dot add. Okay, and here you are just going to add nums of I. Okay, this is done. All right, done. Okay, so this is done here. So in the unique list we have added all the elements. Now just create one variable int count and set it to 0, and then you have to start from 1. Okay, int I is equal to 1, and you don't need to check the last one also. So here I'm just going to write unique list dot size, and here minus 1. Okay, this is what I'm going to do here, and here I'm just going to do I plus plus. All right, so now here inside this, what is going to be my prev, okay, and what is going to be my current point, okay, and what is going to be my next point. Okay, these three things I have to check. Okay, so here I'm going to say unique list dot get, and here I minus 1. Okay, I minus 1. All right, so this is for prev. Okay, same way for cur. Okay, so you have to just copy this. Okay, come here and here just paste it, and here for I. Okay, same way. Now next is going to be unique list dot get I plus 1. Okay, so now for one particular index, okay, you have prev, cur, and next. Okay, so now here inside this, just one if condition you have to write. Okay, if cur is greater than prev, okay, and cur is greater than next. Okay, this, okay, this is what you need to check. Okay, if this is valid, or if this is valid, cur is less than prev. Okay, and here cur is less than next. Okay, if this is the case, then simply increment the count. Okay, count plus plus, and here in the end simply return the count. That's it. Okay, return count. All right, so now let's run the code and see if there are any code issues. We'll try to fix that. So see, all the test cases has been accepted. Now let's submit it. So see, our session is accepted, right? Okay, and the time complexity for this, you can simply say that it is going to be of n only, right? Okay, So since we are running this for n times, okay, nums dot length, okay, this many times, then whatever the list we are going to get, okay, let's suppose all the elements initially are also unique only, there are no duplicates initially as well. So then in that case also this is going to run approximate n times, okay, if it is very large n value, right? So of n plus of n, so you can simply say of n only, okay, 2n, that's equal to of n only, right? So time complexity is of n, right? So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in the comment section. Till then, keep coding and keep practicing. Meet you in the next video. Thank you. Bye bye.